Hey Buford Middle School students, this is Mrs. Wilborn again, and we're back in our Unit 6 Probability. This is Lesson 2, and this lesson is going to be about sample spaces. Alright, and our essential question for today is how do I determine a sample space? There's a couple things that you need before you get started, so of course make sure your guided notes are with you, make sure you have a pencil, make sure you're in a quiet place, but you're also going to need some colored pencils, markers, or highlighters. Specifically, you'll need blue, orange, green, and yellow. So if you need to pause the video and go grab those colors, go ahead and do so, and then you can go ahead and join us and restart the video. Alright, you got two vocabulary terms for this lesson. The first one is sample spaces. And a sample space is simply a list of the individual outcomes of a given experiment. Their probabilities add up to 1, or the sum of their probabilities add up to 1. Alright, so we'll give you some good examples of these, but basically you would list out each of the possible outcomes and find the probability of each of those. A uniform probability model is when all of the outcomes of an event are equally likely to occur. So you'd have to create a sample space, and then based on your sample space values, your probabilities, you could determine whether it was a uniform probability model. If all of the outcomes are the same, then yes, it would be a uniform probability model. Well, let's go ahead and look at a couple examples. Alright, here's our example number 1. We have, first thing you need to do is to color code your marbles on here. Alright, they are not color coded on your notes page, so you will definitely need to just kind of go over those. So if you need to pause the video, go ahead and do that while you're color coding to make sure you have those the same. Alright, the question says to determine the sample space for randomly choosing each color of marbles shown, then determine if this is an example of uniform probability. Remember, a sample space is a list of the individual outcomes that are to be considered. Their probabilities equal 1. Alright, so let's go ahead and take a look at this. First thing we have to do is we have to go through and find the probabilities of a blue, a red, or a green. Alright, so let's go ahead and do that first. Alright, remember our formula for this is going to be probability. I'm going to change my color here. Maybe this you might be able to see it a little bit better. Alright, probability equals successes Sorry guys, I want to erase this real quick. Alright, probability equals outcomes over total. Okay? Alright, so let's look at blue. Alright, so our probability of blue being pulled out, and we have 3 blue marbles, is going to be 3 over the total number of marbles, which is 10. Alright, so 3/10. Alright, then the red, so probability of red, again, if we're writing it on the screen, you should be writing it on your notes. Probability of red, well, there are 3 red marbles, so it's going to be 3 over the total, which is 10. And then finally, probability of green, we have 4 green marbles, so that's going to go in my numerator. Alright, that's my outcomes, 4 possible outcomes, and over 10 total marbles. Alright, so what I've done is I've now created a sample space. Alright, this is showing the probability of each outcome. That's what a sample space is, when you kind of list out all the possible outcomes and then give the probability of each. Alright, the question asks us to determine the sample space and then also determine if this is an example of uniform probability. Well, since each of these outcomes, since we have the green here, and the green has an outcome or a probability that is higher than these two, the blue and the red, this is not a uniform probability model. Alright, if the outcomes were all the same, if the probabilities were all the same, and if green we only had 3 green marbles as well, then yes, it would be uniform. So this is not uniform because all of the probabilities are not the same. Okay. Another thing, a good strategy that you should do to check your sample space just to make sure that you calculated it correctly is to make sure that all of the probabilities add up to 1. So what I could do here is I could say, okay, 3 for the blue plus 3 for the red plus 4 for the green and put that all over 10. So I'm adding all of my numerators up and putting it over 10. Alright, so 3 and 3 are 6 and 4 are 10. So, since 10 over 10 does equal 1, that means that yes, I've calculated my sample space correctly because the probability of each of the possible outcomes should equal 1. Alright, so that's just a quick double check that you can do. Alright, so this was not uniform because the probabilities in our sample space were not all the same. So good. One more example. Okay, so in the change pouch of your wallet, you have the following coins: 3 pennies, 2 nickels, 4 dimes, and 1 quarter. Determine the sample space for randomly choosing each type of coin and determine if this shows uniform probability. Alright, well let's go through again. We have to find the probability of each event happening. So, alright, let's do our pennies first. So the probability, and I'm going to abbreviate, of a penny is going to be, well, I got 3 pennies. Alright, 3 pennies. Total number of coins is 3, 5, 9, and 10. So I have 10 total coins, so that goes in the denominator. Alright, probability of nickels. Well, I got 2 nickels, so my outcomes, favorable outcomes, is going to be 2. My total possible outcomes is 10. That's always going to stay the same in a sample space. Alright, my probability of pulling a dime. Alright, well, it says I have 4 dimes. Alright, so 4 favorable outcomes over the total. Alright, and then finally my quarters. Alright, well, I only have 1 quarter. Alright, so probability of pulling out a quarter, favorable outcomes will be 1, total outcomes is 10. Alright, and so now what I can do is look at my sample space, and obviously because my numerator numbers are different, this is not uniform. This is not an example of a uniform probability model. Alright, because my outcomes are different. Now, again, if I go through and I add all my probabilities up, add my numerators, 3 and 2 are 5, 5 and 4 are 9, 9 and 1 is 10, that's a double check that I didn't make a mistake because 10 over 10 does equal 1, and my sample space, when I add my probabilities together, I should get a 1. Now the scale is down here because what you could do, and what you may be asked to do, is to actually plot each of these on a probability scale. So if I were to do that, I would have 0.3, 0.2, 0.4, and 0.1. And so I would plot those. Obviously 0.4 is going to be my highest, and I know my 1/2 is 0.5, so they're all going to be kind of randomly placed throughout, below that 1/2 mark. Okay, so anyway, you may be asked to actually plot each of the sample spaces or plot the sample space on a probability scale, and so you would just want to go through and do that. Okay, now we're going to move to the your turn questions. You have 3 your turn questions. Before you move on, what I need for you to do is to take a minute, and you may need to pause the video, and I need you to color code this spinner so that you have it to answer the questions. It's black and white in your guided notes, and so you'll need to take those colored pencils, markers, or highlighters and just go ahead and color code these the same colors, the spinner section, so that you can answer the question appropriately. Alright, other than that, you have 3 sample questions or 3 your turn questions. and get those done, and we're going to check those tomorrow in class. Certainly be sure that you're jotting down any questions that you may have so we can review this. All right, guys, have a great night.